Here we go. Step one, completing the square. What do we do first? Multiply everything by 2. Okay, so far so good? Then what? Move the 4 so that you can complete the square. Now, what completes the square? Half of 12 squared. So 36 on both sides. What's your perfect square? X minus 6. Over here we have 2y plus 32. So one way to do it would be like this. And I can see that my vertex is positive 6, negative 16. How many of you got that as your answer? Okay, good job. If your hand is not up in the air, Vincent, did you see what you did wrong?
Yeah.
Not ever going to do it again.
No, it's dumb.
Now, yesterday we also discussed that we could have found the vertex, not on the quiz because of the directions, but we could have found the vertex with our axis of symmetry formula, right? So let's review that real quick. If we were doing it that way, then our x-coordinate would be negative b over 2a, which would be 6 over 1, so 6. And then to get the y, we would simply plug in the 6. So that would be 36, half of that's 18, minus 36 plus 2. So 18 minus 36 is negative 18, negative 16. Yep. Okay? All right. Now, let me get through a couple of things, and we'll look at some homework questions that you might have. First thing I want you to do is go to your homework page in your book, which was page 183, and look at problem 40. Actually, let's look at problem 42. Okay, so we've got we're looking at number 42. All right, now here's the plan. We're going to do exactly what we just did, only backwards. Because now I know my vertex, and I'm going to write the equation. Now I erased it, but you know, I can't remember exactly what I had there, but I had something like this as my equation. And if my equation looks like that, then I can see my vertex. So let's do this backwards. I know my vertex is that. So what do I know about my equation? Without doing any work at all, I know what? I have y minus 5, and I have x plus 1 squared. Now, what's missing? That is not the final answer. What's missing? The coefficient out here, and you can call it whatever you want. Here's the deal, folks. There are a lot of parabolas that have that vertex. If you write this, all you've told me is there's a parabola out there with the vertex negative 1, 5. True statement, right? But could that parabola look like this? Or could it look like this? Or even could it look like this? Yes. That coefficient controls the size and the direction. You know that from the last work that we did. If you put a multiplier on it, it stretches or shrinks, right? So we want to know what multiplier is it going to take to get that parabola to be fat enough to go through that point right there? Do you have an idea how we might figure it out? Will?
Plug the vertex into the equation.
Plug the point, yeah, not the vertex is already in there. We're going to plug this point in, yeah. This is an x and a y that have to fit in this equation. So if I put negative 13 in here and 2 in here, then I should be able to figure that out. So what have I got? Negative 18n equals what on the other side? 9. So n equals negative 1/2. Does it make sense that that number would turn out to be a negative?
Mm-hmm.
Why?
Because it goes upside down.
Because the parabola is upside down. Everybody okay with that? Okay, something else I'd like you to look at while we're here. Numbers 45 through 48. Not a big deal. Just want to make sure you understand the language. When I look at number 45, I know those data points aren't exactly in a straight line, but that is a strong positive correlation. They're pretty much linear, right? And when we say positive, the slope of the line is positive. Now, look at number 46. 46 is not as strong, but it's still pretty strong. They're pretty much in a line, only this time the correlation is negative because the slope of the line is negative. Look at 47. Would you say positive or negative?
Positive.
Positive. Would you say strong or weak?
Weak.
It's pretty weak. There's still correlation. You still could build a line through there, but those points are getting more spread out. What about 48? There's no correlation in number 48. You don't know whether it's going up or down or whatever. It's just a bunch of discombobulated points. All right, now let's look at number 56. I promised you some word problems today. Here we go. Number 56. We have a painting. And what do we know about our painting? It's 3 feet longer than it is wide. So tell me about my variables. X and x plus 3. Right? The wooden frame, if the wooden frame is 12 inches wide, the area of the picture in the frame is 208. Okay, so I'm going to put a frame around this. And did you notice what's the unit on the frame? Inches. And what's the unit on the picture? Feet. So let's change the unit on the frame to be what? Feet, so that this would be a 1. So the frame is 1 foot. And the area of the whole shebang is 208. Set up an equation for me. It's a rectangle. How do you find area? Length times width. So 208 is going to be the length times the width. What is the length of this thing?
X plus 4. X plus 5.
And here, x plus 3, x plus 4, and x plus 5.
Plus 5.
Everybody get why it's x plus 5? The length of the picture alone is x plus 3. How much did you add on this side? And how much did you add on this side? 1 on each side, right? X plus 5. What about the width of the whole thing? X plus 2. The width of the picture alone is X, and you added 1 at the top and the bottom. What kind of an equation is that? Quadratic. You solved 1,000,000 of those. What are you going to do? And if you tell me you're going to set these equal to 208, you should be smacked. The only time you can set these equal to something is if it's 0. You have no choice. What are you going to have to do here? Foil it out, get it set equal to 0, and then maybe refactor, or use your quadratic formula or something. What is that, negative 198? The absolute only reason I can factor this, I would never in 1,000,000 years have been able to factor this, except Miss Ludington and I were having a conversation the other day about the multiples of 11, because that's what math teachers talk about. And so I recognize 198 as one of my multiples of 11, so I thought 11 times 18, aha, that gives me the 7, so there we go. Otherwise, I would have been using my quadratic formula, probably. Okay, so I come up with 2 answers, x equals negative 18 or positive 11. Tell me about this answer right here.
Doesn't make sense.
It's extraneous. It does not make sense in the context of the problem. Dan, is there something on that iPad? So x equals 11, and x plus 3, that would be 14. So what was the question? Dimensions of the painting? We have them. It's 11 by 14. You okay with that? Let's try another one. How about 58? Number 58. You know how the box problem is kind of a big, well, you don't know this, but I told you, the box problem is a big deal. These revenue problems are also a big deal. Revenue is determined by taking the number of items you sell times the price each. Do not overcomplicate this concept, people. Think about it for a minute. If you made Rice Krispie treats and you sold 12 of them at $1 each, how much money would you make? $12. The number you sell times the price each, that's how much money you bring in. Now that's not profit, right? You see the difference. This is simply what you are bringing in. Revenue. Okay, so when I look at this problem, which involves revenue, making money, how many, and I'm not really selling the apartments, but I'm renting them. How many am I currently renting? 800. So I'm starting with 800. How much am I currently renting them for? $300 each. So if somebody said to me, what is your current revenue? The answer would be 800 times 300, right? That's pretty simple. But things are changing. What's changing? What are we going to do? What are we thinking about doing? Lowering the rent? Lowering the price? By how much? So I'm going to be taking away 5s here. Do I know how many 5s I'm taking away? No, but I'm going to, each time I subtract, I'm going to subtract 5. Now what's going to happen every time I take away 5 from that 300? I'm going to increase this number by 20. So if I lower my price one time, my rent would be $295, and I would rent 820 apartments, right? If I did it twice, my rent would be $290, and I'd have 840 apartments rented. Do you see how your income is going to be changing? You, as the business owner, want to make your income as much as you possibly can. So we're going to maximize this. So what do we really need to figure out then? How many times do we need to change the price? Isn't that what we really have to figure out? Do we lower it once or twice or 3 times? How many times do we have to do it? So let's let X be the number of price reductions. Every time I lower my price, it goes down $5. So what if I lowered it X times? What would my new price be if I lowered my price X times? 300 minus 5X. Every time you lower it, it's worth minus 5, right? Now, how many apartments would I rent then? 800 plus, that number's going up, plus 20X. Because every time you lower the price, you add 20. And that will be your revenue. Now, what did we say we wanted to know about this, or what's our goal here? Our goal is to maximize revenue. What kind of equation would that be if I FOILed it all out?
Quadratic.
A quadratic. And what does a quadratic look like when you graph it? A parabola. And this parabola, look at your x squared term. When you FOILed out, your x squared term would have a negative, which means what about this parabola? It opens down. Wait a minute. I have a parabola that opens down, and I'm interested in the maximum. So what do I really want to do with this equation? Find the vertex. Do I know how to find the vertex of a parabola? You just took a quiz over it. So what do you want to do with this equation? If your goal is to find the vertex without a calculator, what are you going to do? You're going to FOIL it out first, right? Once I get it FOILed out, I'll negative b over 2a. I think that'll be the easiest thing, but I can't do it in this form. I need to get it multiplied out. So this will be 24, how many zeros? That's right. Minus, plus, keep an eye on my arithmetic, please. So I've got, if I multiplied right, negative 100x squared plus 2,000, did I multiply right? 2,000x and then 24. 240.
What do you get x by itself?
Well, you absolutely could divide everything by negative 100, move the 240,000 over, and complete the square. But I like Emma's idea. I really just want to know the vertex, right? And so I can do negative b over 2a and come up with x equal to 10. So my vertex has an x-coordinate of 10. Now wait a second. What was the question ultimately that we're answering?
Maximum revenue.
Is that what it says? Does it say find the maximum revenue? Let's read the question. Let's make sure we answer the question. I don't want to do more work than I have to. think the question ultimately is C, what rent will yield Welcome Home the maximum monthly income? What rent? In other words, what should I charge to make the most money? What does this X stand for? What does this 10 stand for? The number of times I reduce the rent. And every time I reduce it, how much is it worth? 5. So if I reduce 10 times, I'm really going to take away 50 from an original price of 300. So what's the new rent I should charge? $250. Notice that I didn't even really need my whole vertex. I didn't need this number to answer the question that was asked. What would I need that number for? Remember, that's your Y value. What would that number represent? The actual revenue. So if the question said, find the maximum revenue, that would be your answer. But we didn't even need it. See how that works? All right, let's try the next one. The Sweet Drip Beverage Company selling soda pop. All right, so let's build our revenue equation from the bottom up. How many am I selling at what price right now? Right now, how many am I selling?
26,000.
26,000. What am I selling them for? 50 cents a can. Everybody good with that? Now, what's happening this time? There's going to be some changes. What's happening this time? The price is going up. So this time, instead of having the number of price reductions, we're going to have the number of price increases. And how much are these going up by? 5 cents a nickel? So the price is going up in nickel increments. What's happening to the volume, the number that I sell? Going down by 1,000 at a time. So what's this equation going to look like? By the way, I hope you notice that it's a basic economic fact. If the price is going up, the number you're selling is going down. If the price is going down, the number you're selling is going up. So one of these is always going to be added and one of them is always going to be subtracted. So the parabola you end up with will always be opening down and you'll always be able to find the maximum. Okay, so what's this equation going to look like? Revenue is going to be what? Well, how many am I selling? 26,000 minus 1,000x. Every time I raise the price, I'm losing 1,000. 50 cents plus 0.05x. There's your equation. That's your revenue equation. Number sold, pricing. Now, what is the question? How much should they charge? And what will be the maximum revenue? So this time we need the vertex, both coordinates. So take a moment, see if you can find your vertex. How are you going to start? What are you going to do first? FOIL. Feel free to use your calculator. pages. Which means you should charge, remember they're all worth 5 cents. So that's a 40-cent increase on top of the original 50, so that's why I said 90 cents a can. How did I get 16,200? Where did that come from?
Plug X into the equation.
Plug X into the equation, and actually when I did it, I plugged it into this equation, and certainly you can plug it in, it doesn't matter which form of the equation you put it in. But X is 8, so you just plug 8 in and subtract. Any question about that, Robert?
How'd you get, so like when you get the 90 like cents, how did you get that? I'm not
How to
clear.
get 90 cents?
Yeah.
Okay, remember, 8 is the number of price increases. Each increase is worth 5 cents. That's a 40-cent increase.
So would you multiply 8 by 0.05?
Uh-huh.
And then that's what you get 40% or
That's 40 cents.
40 cents and then,
Add it to the original 50.
okay.
Okay? Well, there's one more of these in this section. You have time to try it. So with your group, would you do number 60? It's a little bit different in the wording of it, but it is exactly the same type of problem. So get busy with your partners, please. Let's see if we can get this thing done.
Okay, so it's so it's like 15, 30, 50,000 equals revenue, because that's basically the sales per people or the units sold. Like effectively, the price each is 50,000, and then how do you increase the amount of salespeople buying more? You're gonna lose customers.
And then the price, like, so like the price of the price of each is 30,000. I mean 330 salespeople. Or is that is it 1,000?
I know 50,000 going down by 1,000. And I think it's
So that's like minus 1,000.
I think it'd be one.
And then minus plus 30.
People, and then you just gotta.
Oh yeah. So it'd be and that's 30 plus 1.
Yeah, that's what I was saying.
I know it's a little different. It doesn't talk specifically about revenue, although we're talking about sales for the company. Did you start with the basic notion that you got 30 people selling $50,000 each?
Yeah.
Isn't that what's happening? Now, how is that going to change? That's going to change. How is it going to change? You're going to start adding people one at a time. But every time you add somebody, this number goes down by 1,000. So what do we really want to know this time? What's our X stand for? The number of new people that you are going to hire, right?
Yeah.
So let's see. How am I going to build my sales equation this time? I'm going to start with 30, and what's happening to that? It's going up by 1x, one at a time. And sales, which started at 50,000, is going to do what? go down by 1,000 every time? I don't know where you're at. I got 10 for X. What's that stand for? 10 what? 10 extra people? What was the question? How many should he hire? The answer is 10. You okay with that?
Yep.
All right, here's what I want everybody to do. I want you to take your iPads out, and I want you to send Dan an email wishing him good health.